on hypotenuse leg, you have to establish right triangles. So must establish right triangles. Okay, so you may be given perpendicular lines. What do we know about perpendicular lines? What do we know about perpendicular lines? They form 90-degree angles. So if we look at that very first question on your homework, question number 1. Question number 1 told you that BD is perpendicular to AC. Whenever you're given perpendicular, what are you going to look for? What does perpendicular? Becky? They form 90-degree angles. So we're going to look for, I lost my pen. Where did it go? Seriously? This is not a good time. We're going to look for right angles. And the reason's going to be definition of perpendicular lines. Okay? So given perpendicular lines, we will look for right angles. Then, and we will establish the fact that there are right angles in that triangle. Then from there, you will establish that the triangles are right triangles. So if we look at question number 1, this is from last night's homework. This was our picture. And we've got AB, DC. All right. If we're told that BD is perpendicular to AC, where are the right angles? You know, this is like, we found the murder weapon. Now we need to establish a tie of this murder weapon to Devin. All right? So we've got our perpendicular lines. What do we have to establish based on these perpendicular lines? Right angles. So if we begin our proof, the first thing we're going to say is angle ADB and angle CDB are right angles. And how do we know this? Because we were told what? Perpendicular lines. Now, have we established our right angles? Are they there? So now if I have right angles, what kind of triangles must I have? Harper? Right. Triangle ADB and triangle CDB are right triangles. How do I know that? What's the definition of a right triangle? Triangle that has a 90-degree angle. Now, this has established, I have established right triangles. What they gave us on this problem is they told us that AB is congruent to CB. And then what else should we be able to pick up from our picture, Brittany? Norwood? Okay, we weren't given the bisector part, just the perpendicular. But looking at that picture, what's special? What do they share? DB. All right, they share DB. So opposite the right angle is the hypotenuse. Forming the right angle is the leg. So this is now where we go into our hypotenuse leg. We know that AB is congruent to CB. And if we look at the worksheet, this statement is in the given. That is why it's given. Now, we picked up on BD. Why is BD congruent to BD, Caitlin? This segment, why is it congruent? The perpendicular gave us the right angles. The right angle gave us the right triangle. But this is a shared side. What's the reason for a shared side? I think you've written this before. Starts with an R. There you go. Reflexive. And then all of this stuff together brings us to triangle ADB being congruent to triangle CBD by hypotenuse leg. So in your notes, if you have a highlighter, I want you to highlight that right triangles must be established in order to use hypotenuse leg. It's the same stuff as we've been doing. I'm going to use some parallel. Remember, I promised to put second period's notes online, and I would go beyond what we did. If you listen to those notes, you got the parallel. All right, so let's just go, when you're given, let's go here. When you're given parallel lines, what should you look for? There's all sorts of angles. When you're given parallel lines, look for what? What kind of angles do we work with on parallel lines? Vertical, no. But those form an X. They're the ones with letters. Corresponding. What did they form? They were the F angles. Okay. What were the Z? Alternate interior angles. What were the C's? Same side interior. And what were the opposite V's? Vertical's an X. That's vertical. Alternate exterior. Now, alternate exterior, alternate interior corresponding, they're all congruent. Same side were supplementary. So when you're given parallel lines, then look for these letters. There are angles there that are congruent. So I'm going to do problem 6. And I'm going to show you how we're going to adjust. So on today's homework, you will write, this will be on notebook paper, it will not be on the worksheet. You will write the given, FJ parallel to GE, EF parallel to JG, and they told us that the proof, we are going to prove that triangle EFG is congruent to triangle JGF. Okay, you will write that. You will draw your picture. Well, that's just a tad bit off. You will label it. We've got E, F, J, G. All right. So we are given parallel. So we're going to start and we're going to write FJ, that's a J. FJ's parallel to GE, and EF is parallel to JG, and that was given. So let's just work with these top parallels. It does not mean those segments are equal. Those arrows mean parallel. What letters F, Z, C, or disconnected V's are formed by those two parallel lines? a Z. And remember, to form the Z must be part of those parallel lines. So what angles are congruent because of that? How do we name that one, and how do we name that one? So we're going to say angle. Can someone, let's see, we're going to ask Leslie to name this upper one. We're going to name this upper angle. Well, use 3 letters. How do you use 3 letters to name this angle? There you go. J, F, G. Now, because you're drawing the pictures, could you put a 1 here? Yes, because I will be able to look at your picture and see where 1 is. All right, so we're going to have McKenna name this one down here. Now, she went J, F, G. What do you have to do? Excellent. Angle EGF. Now, what's this reason? This is where that spreadsheet of geometric terms comes into play. I asked you to highlight this yesterday. If lines parallel, what type of angles are they? Angles? Alternate, ALT, alternate interior angles congruent. Okay, I'm going to take away my parentheses today. And I'm going to show you how it's going to look. All right. So anyway, I guess what I should be doing is marking my picture. All right. So we have those 2 angles. If these 2 sides are parallel, what letters formed by those 2 sides? What letter? Okay, if I trace these 2 parallel sides and they're transversal, do I have another Z? But I have a different pair of angles. You see my different pair of angles? Now the green angles are congruent to each other. All right, we need a side because angle, angle, angle doesn't work. Where's my side? Eric? What's special about those 2 triangles? They're stuck together. Special relationship when they're stuck together. They should share something. Yeah. Brittany? They share the side FG. See it? Okay. This side FG is in this triangle. Okay? And this side FG is in that triangle. So since it's the same segment, doesn't it have to be equal to itself? Okay? So what combo is this? What 3 letters? You all are good at this. Look at one triangle. What combo? Side, 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 angle, side. What is this? Angle, side, angle. So we're going to say angle, side, angle. All right. So do you see these double marks we just did? MJ, can you name this angle right here? Angle EFG. Can you name the other one so that it corresponds? Good. Angle JGF. And what's the reason? Well, what kind of angles are they that form a Z? Alternate interior because they're in between the parallel lines. If lines parallel, alternate interior angles are congruent. And let's see, Samantha, what's my side? FG is congruent to FGY. Reflexive. All right, so this is how we're graduating. Yesterday was more, those last 2 days were a flow chart method. What we're doing now is we're drawing a line between our statements and our reasons. So this is statements. This is how it differs today. All we're doing is separating our statements from our reasons. We used parentheses to do that the first 2 days. Now we're going to use a line that's going through that. All right, so now I can now say triangle EFG is congruent to triangle JG something. JGF, and what's this reason? What's this reason? Angle, side, angle. Angle, side, angle. Now, we number our statements and we number our reasons so we know who goes to whom. So this is just like you've been doing, except we're getting rid of the parentheses. This should be a 4. 4 comes after 3. And we're writing everything vertically. So this is the statement I'm making in court. This is my evidence. This is my justification. I have made another statement in court. This is my evidence. Another statement. This is my evidence. You with me? If you tell me this, then you should be able to tell me why. If you tell me this is true, then you should be able to tell me why. And I'm telling you now, it's all about what you've been given. Okay? This is our destination. So this should be the last step of your proof. This is where you go to see what needs to be done. All right, we're going to now, I'm going to go down to number 9. Unless, pardon? Mm-hmm. Do you see the slight shift we did in the format? I want, instead, this last statement, instead of being over here, is down here. That's the biggest change. All we've done is put a line between our statements and our reasons. Number 4 has parallel lines, but they weren't Z's. Number 8 had parallel lines, but they weren't Z's. Okay, so now we're going to go to number 9 to make my next point. And I went there yesterday, if you heard second period's notes. And we're going to go there with you all today. And I told second period that they would do something. And it was like, no, we won't. And guess what they did? All right, here we go. So I'm doing this in the format of today. I'm really not teaching you anything new. It's just that we're subdividing our statements from reasons. All right, so JP bisects HJK. And then we've got, I should have said PJ bisects angle HPK. All right, and then we are going to prove, what are we proving? We are proving triangle HJP is congruent to triangle KJP. All right, so now, this is an important concept. If I hand you an apple, and I hand you a knife, and I ask you to cut the apple, what will you have? 2 halves of what? Apple. Okay? If I hand you a strawberry, and I ask you to cut the strawberry, what will you have? Strawberries. If I hand you a watermelon, and I ask you to cut the watermelon, what will you have? Watermelon. 2 pieces of watermelon. If I gave you an orange and I ask you to cut the orange in half, what will you have? What do you have? 2 pieces of orange. If I bisect an angle, what will I have? I'll have 2 angles, not 2 segments. If I cut a strawberry, I'm not going to have cantaloupe. If I cut an apple, I'm not going to have an orange. You with me? If I cut an angle, I will have angles. I will not have segments. If I cut a segment, I will have segments. I will not have angles. All right, got it? All right, so that's where some people before school went haywire on the homework last night. So I have an angle. So let's get our format started. All right, so what can you tell me if JP bisects angle HJK? What should be produced? Travis, if I cut an angle in half, what should be produced? An angle. How many angles? So if I'm cutting this in half, what should happen? You see the two separate angles? Would it be this one and this one? If I cut this in half, do I produce two little angles? Okay, I'm not going to produce two equal segments. I'm going to produce two equal angles. What if we come down here and we cut this guy in half? What are we going to have? What will we have, Kayla Shipley? If I cut this angle in half, what will I have? Two equal angles. And do you agree if I'm cutting this angle down here in half that they should be right there? Okay. Now, what else on that picture should you be able to see? Notice, this gave me that pair. This gave me that pair. I'm out a given, which means go to your picture. There's another something there. Eric, I'm going to ask you this time. What should you pick up in that picture? Brittany helped you last time. What do you see? Okay, we've got our two angles up here. We got our two angles down there. We're done with angles. Because if we get these angles, angle, angle, angle doesn't do it. There should be a side. Where's the side? Yes, why? Yes, JP because they share that. So what is our combo going to be? Angle, side, angle. But first, we have to state that JP bisects. This has to be here because this is important information. HJK. Now, if they said HP was congruent to KP, I wouldn't put it here. I'd put it where it belongs. And then we've got PJ bisects the other angle. Okay? You have to introduce this as evidence in order to state what we're about to state. So number one, this was given. Okay, so now we're going to go to our angle, side, angle. So I need a pair of angles. Which pair of angles do you want to do, Kayla E? You've got two pairs. You pick it. Pardon? PJK, all right, is congruent to what? Good. Angle PJH. Now, why? Why did we mark that? Why were we told that? How did we know? Definition of what type of bisector? We have angle bisectors and we have segment bisectors. Definition of angle bisector. And I'm going to give you very picky. If you just tell me definition of a bisector, I will not give you credit for the reason because we have several. All right. What pair of sides do we have, Devin? JP is congruent to JP, and he told us that the justification, oh, that's a P. The justification for that was reflexive. All right, so Nick is going to tell us our other pair of angles. What's our other pair of angles, Nick? Angle. Kayla got the singles. PJH, she already did. PKJ is this one, and it's not marked. Remember, the vertex has to be in the center. H, HPJ is congruent to angle KPJ. What's the reason? No? What told us this? Definition of angle bisector. All right, so now how do we conclude? What's our last statement? Tommy, what's our last statement? After we have our angle, side angle, what do we say? This is the punchline for the jury. We have set up our case. Triangle, right? Congruent to. And what's the reason? We have it. We thought ahead. It's a combo. Angle, side angle. Any questions on the switch that we're doing today? All right, you've got about 4 or 5 proofs on your next test. So it's important that we nail this. All right, by the time we're finished, you will have done 31. Just